Thank you for joining Tech Tuesday, number 26. So it's practically been a year. We will start with a moment of silence. Still a war going on, hostages. I want to continue talking today about IP strategy, but I realize that it's difficult to talk about IP strategy disconnected from everything else. And what I want to point out today is that IP and research and development are actually, at least in startup companies, an indivisible unit. You can't really talk about one without the other. And I first want to talk about two games which are well known to be strategy games. The game of Go, which now AIs can beat the pants off human users, is a well-known East Asian strategy game. And what's interesting is you can't move any pieces, you can only put down new pieces. Chess, which is also a well-known strategy game, you know, coming from Persia, but now the West, Russia, and so on. You can't add any new pieces, but you can move existing pieces. Now, if you think about it in a startup, you do both things at the same time. A patent, you file a new patent, that's like putting down a new stone, and in fact, the goal is often similar. It's in order to protect part of the landscape. And while R&D is really about, you know, creating new ideas, new products, new options, if you look at it from the company perspective, what the company is doing is they have some sort of product design in mind. And when they do R&D, that product design is changing as a result of the R&D. And when we talk about IP strategy, we should be thinking about both of these types of activities. And not only that, we should also be thinking not only at the client side, but also on the competitor side. And just to give you a feeling for it, the classic example is the competitor has a patent and you do R&D in order to design around the competitor's patent. Okay, so I think you notice that IP seems a bit static and R&D seems a bit dynamic. So I did a little bit of contrast and compare between R&D and IP. So IP is kind of stable, but it's relatively cheap and can cover a lot of options. R&D can move. Say move, I mean move the product, and sometimes you have to do it, but it's not so cheap. R&D has a core function not of moving product design, but actually of creating value for the company. And IP, while it can create value, the core function is protecting and enabling value extraction by the company. R&D often tells you what IP you should file or what IP you can file. IP often tells R&D what direction it should go in. R&D usually starts where you have the biggest risk. Startups are about reducing risk and uncertainty, and maybe the correct word is uncertainty. So you start the R&D where you have the biggest question marks. IP probably also should, but the place which has the greatest IP risk could have nothing to do with where the R&D has the greatest risk. And the difference, R&D is guided by the company vision. Here's what we're going to build. And IP should really be guided also by the competitor vision, because the competitor might do something to you and might not. Talk about strategy. We talk about moving by doing R&D or putting down new castles by doing IP. There's some things happening in the background, which is what the strategy is about. First of all is time. We've heard the expression move fast and break things. And what it's trying to say is, if you're going to be first, there's a first mover advantage. Okay, you want to be the first one with the product, the first one with the data, the first one improving their product. And the corollary is that if we can slow down our competitor, that's good. Same thing with money. There's a finite amount of money, and you can spend it, and when it runs out, you're done. Uncertainty. Every startup has a lot of uncertainty involved. The question is, how much uncertainty can you tolerate, and where can you, in which part of the business can you tolerate it? IP is wonderful for increasing uncertainty in the competitor. R&D is wonderful for reducing uncertainty on your side. Depending on, like I said, what the company we're talking about, this can make or break. We've all heard about companies shutting down because the investors decided they're just not sure it's going to happen. So all of these, time, money, and uncertainty, you spend them in the startup company, but you also do activity in order to increase your time, increase your money, and get you more resources to deal with uncertainty. And I'm not forgetting that IP is not the only tool being used, but guess what? It's the only one we're going to talk about today. Last but not least, IP is always time limited. And it doesn't matter if it's limited because it dies of old age or because new technology comes around and you don't need it. And what that means is that the amount of IPs that you need is not the maximum, but sometimes just enough for a different mode to kick in. Let me give you an example. I'm competing with somebody else in one of these winner-take-all markets that there can be only one winner. And if I used IP in order to slow down my competitor enough for, let's say, network effects to kick in, or perhaps friends in my government effects to kick in, I don't need the IP anymore. So an important thing to think about is that while we all want IP, which is a complete block and stops everybody, sometimes you don't need that. Sometimes you slow down your competitor by 6 months, you cause him to spend another $2 million, you increase the uncertainty by 20%. Sometimes this is all you need in order to have victory, whatever that means. So I mentioned winner takes all. Here's an imaginary scenario, which I'll use a little bit. An AI operating system. Okay, we all have computers, they all have operating systems. Next stage is operating systems which are specially designed for use with artificial intelligence. If we're successful, it could look like Microsoft and Windows. Okay, Microsoft basically monopoly on desktop operating systems. Why? Because people like standards and the strong network effects. Of course, maybe nobody needs an AI operating system. You have a client called, I can't even pronounce the name, IOSI, and they want to make an operating system for AI. Now, the very first issue we have to think about is the following. Let's assume that IOSI is the first company in the field of AI operating systems. And we expect that they're going to be what's called follower competitors. That's competitors that see what you're doing and say, hey, we want to do it too. And the decision that the competitors are going to make is, should they compete? Should Microsoft start making an AI operating system? Okay, the competitor. And that's the very first issue that other companies have to think about. And even if they decide that they want to enter the field, maybe we can guide them to compete in a place where it doesn't bother us so much. And maybe we can guide them to compete in a place that we know is bad. And that will, of course, cause them more damage. And the answer to the question is yes. And let's talk about how IP and R&D interact in order to do that. So I'm going to show you two charts. And each chart is a kind of chart that you might show in a decision meeting where people will try to decide, let's say Microsoft, should we go into the AI operating system field or not? And chart 2 shows what happens if we add AI. So on the left, for each technological direction, I gave a risk score, and the risk score is built out of a combination of, I oversimplified, of course, regulatory uncertainty, resources, difficulty in marketing, and difficulty doing R&D. And I assume that there's 4 different directions. We can make the kernel itself AI. We can use a Linux kernel and build something above it. We can focus on the APIs that AI can talk to somebody else's AI, or we can focus on the whole issue of privacy. How do we maintain privacy of data in these operating systems? Now, our company, AOC, prefers to go into this field. They think going into this field is a bad idea. They don't care if somebody goes into this field, and if they can't go in here, they're willing to go here. Now look what happens if we file some IP, and the IP is in blue, how it changes the decision making. If Microsoft would look at this list, and let's assume that the outcome is equal, they should choose exactly where we want to be, which isn't good for us. But if we file a significant number of patents over here and make sure everybody knows about it, and perhaps file a few patents over here just to make it even less comparable to other choices, what happens is that if Microsoft looks at this stacked histogram of risk, they should go with the Linux kernel. Now we think it's a bad idea. Maybe they'll go in a bad direction. That's even better for us. Okay, so to recap, we know somebody's going to have to make a decision. Should they enter this field? And if they enter this field, what direction should they take? And what we do is we file IP in order to guide them to make the right decision. Can't do it without maps. Okay, I oversimplified before because we were talking about just one decision. Now I'm super oversimplifying. Using a map, a 2D map for multi-dimensional problem is not so good, but it's a great metaphor, and it helps us copy concepts from military tactics, so to speak. So here we have a 2-dimensional map, and we have mountains. I hope you can see these mountains. And what the mountains mean, these are locations where there's risk. The risk can be R&D risk, it can be marketing risk, what we showed in the previous slide. Now, what that means is, just one more thing, the space itself is all of the possible solutions to the product that we're trying to make. You don't start at one end of the map and try to get a second end. What you're looking for is something that works. Now, this big green circle is an example of your first step. If you decided to start your R&D over here, so you have a big circle. Why do you have a big circle? Because you don't really know what the solution should look like. So you want to start in a spot where even if you make mistakes, you probably have things that still work. So starting in the mountains is a bad idea because it's full of difficulties, even though the best solution might be right over here. But starting in a flat place, that's a good idea. Now, what happens as you do R&D? At the beginning, you have a big space of possible solutions that you have to maintain as options. As you do R&D, you can converge either within the circle or nearby. So now the circle is smaller, and here it's becoming even smaller because you're shifting to a nearby solution. And sometimes you have to jump to a completely new solution. Okay, so this is a way that I'm trying to metaphorically present what R&D and IP look like on the background of solution space. And I want to say again, this is a map. It's not correct, and what's most incorrect about it is that it's not stable. The risk landscape is always changing. It's changing passively, it's changing dynamically, and it's changing intentionally because we and the competitor are trying to tilt the risks in various directions. Now let's look at this situation. The competitor is over here, this big green circle. What should they do? We file these red triangles. Each one of them is a patent, which covers a certain part of solution space. Now I want you to notice, this dotted line shows that you could design around, okay? If you go from this big green circle along this dotted line, you don't go into the mountains and you don't step on the patent. That's great, except that when you consider the R&D risk, if R&D will try to go here, they might discover that there is no solution. Okay, R&D is still at a stage where they need a whole family of solutions. So by filing these relatively narrow patents, okay, and let's call it a minefield, the competitor, while they could try to design around the patents, the R&D people will tell them, don't, let's go in this direction. It's clear, there's no patents, there's no mountains, this is where we should go, over here. Okay, and I'm emphasizing these patents don't block the entire solution space. Now, what happens if my competitor, instead of doing R&D, is buying ready-made technology? Well, now they need to consider only a much smaller area, and they have no problem just walking around my patents. So if they buy the technology, my patents didn't do much. If they're doing R&D, the patents do. I showed this slide 2 weeks ago. And before I showed, what does a company do when it starts? Let's assume that we're ongoing. If we're ongoing, we can file these patents, and let's call these a patent thicket, as opposed to minefield. Okay, minefields are used to guide the enemy to go in certain places. Thickets are used to slow them down. So if we know where the competitor is going and we file these patents, they don't necessarily block the competitor, but they mean he has to slow down. He might change the order in which they do R&D in order to avoid one of these annoying patents. Now, I just showed you that we filed all of these patents and they're all waiting there and anybody can look at them. But it's better if I can use the element of surprise. Why is surprise good? Because it interferes with the competitive process. Imagine that you have a company and you're planning to do R&D and suddenly the R&D manager gets a phone call from IP telling them what you're planning on doing will probably infringe, you should change what you're doing. So they change what they're doing. And 2 months later, they get exactly the same phone call about a different patent. Okay, you can't work like that. It really interferes with how you plan your work and how you assess your risks. Also, there's an element of FUD. FUD is fear, uncertainty, and doubt. So you can get this kind of surprise when small patents pop up, not big patents, not patents that require you to redo all of your R&D, but small patents which suddenly oh my God, I have to change something. Which means that it's a good reason to file small patents all the time if you know how to do it against your competitor. And if you have R&D leadership, you can identify where it will cause pain. And then you can not only surprise, but also annoy your competitor. So here's an example. I showed before how you do R&D and suddenly you jump. Why is it jumping? Because this little green triangle suddenly popped up unexpectedly. And if it popped up, the competitor has no choice, you see it's completely covering what he's doing, to look for a different solution. This arrow over here can slow down the competitor possibly enough so that you can win. Now, how do you surprise with IP? I'll just give you 3 ways. Way number 1, you hide it in plain sight. You have a patent which everybody thinks is not important, but it actually covers a very crucial feature. And when people get to that stage of the development, suddenly they realize that painting your widget blue is really important. And guess what? That's a patent, blue widgets. Another way is camouflage. You have a patent that has 7 different things in it. Thing number 5 is important. People might look at the patent and say, oh, this is just pieces of garbage. And last but not least, maybe the patent doesn't belong to you. So when people are doing risk assessment, they're not looking for it. Any case, if you know the terrain, and you should know the terrain, you can choose the best place for an ambush. And if you know how the terrain is going to change, then you can choose an ambush point that people don't know about. Till now, I've been talking about the other people. What is happening in the mind of the other people? Hopefully, they're doing calculations, rational calculations, which means that hopefully we know who's making the decisions, what are their considerations, and what process they're using. And if we know all of these things, we can interfere with it. Hopefully, we're aware of budget restrictions. You know, maybe somebody was told you have till December to do it. Well, let's just slow them down by 2 weeks. It's going to be January. How do we use surprise? Perhaps we block them and we force major change in their design. Perhaps we just guide them a little bit. Perhaps we slow them down. Perhaps we extract rent, meaning the competitor has a design, the design built up enough momentum that they have to continue in that direction and walk right into our patent, and they have to pay us royalties. And sometimes we use surprise in order to kick somebody out of the game. We raise the risk so high that the board meets in the other company and they say, no, we're not going to be in this field. Now, I've been talking here about risk and uncertainty, reminding you, previous talk that talks about the difference between risk and uncertainty, especially with regard to IP. Is IP static? said, it's like Go. You put them down and you can't move. What do we do if we have a big flat space? How do we protect it using IP? So one way is to have mobile IP. How do you get mobile IP? Well, we can have a series of filings, each time filing in a different place. But then, you know, there can be prior art. Or we can keep an early application opening and each time take something out of it. So what you see here is that we had 3 applications, and the light red with dotted lines is a scope that the application could have covered, and the red triangle is a scope that the granted patent actually covered. When the competitor sees these red triangles, he sees that you're protecting the entire field. Now, we all know that you don't have enough money and there's prior art. You're never going to get everything. But the competitor doesn't know. So within this triangle, the big one, the little triangle can move around and match what the competitor is doing. So the competitor will look somewhere else. I'll end with a story, and I recommend following the link to read the true story about the Wright brothers, one of the true stories. The Wright brothers built the first working airplane using warping, changing the shape of wings, in order to control the flight. But there are other alternative solutions. Assume that you're the Wright brothers, and you have enough money to file 3 average patents. The question is, where should you put them? Okay, now of course you have to assume a lot of things, but that's exactly the problem that some of our clients face. They're the first ones with an incredible technology, but there are other ways of doing it. They want to block. What should they do? Okay, I am now ending the recording.